welcome everybody once again. And today we are going to be talking about optimizing query performance in Snowflake AI tools. And with us today, we have two very esteemed guests. So I'm going to give a brief introduction about both of them, and then I'll let them take over. So first, we have Maja Ferle. She is a data architect over 30 years of experience, specializing in data analytics, warehousing, business intelligence, and data engineering. As a Snowflake data hero and a book author, she has consistently contributed in data community by her vast knowledge. Skilled in traditional and agile project management, solution architect, and tools like Snowflake, DBT, Tableau. She is a trailblazer in designing robust data solutions. Maya's work exemplifies a perfect blend of technical expertise and leadership. Um, that's a little bit that we can mention about Maja. And then we also have Pooja. Pooja has been a multifaceted leader in the data community. She has also won awards like Women in Tech Community Data Award winner in 2024, and she's also a proud Snowflake data superhero. She's a senior data architect, Snowpro subject matter expert, and author of a Snowflake book as well, showcasing her expertise and in complex challenges. Beyond her technical acumen, Pooja is a dedicated technical reviewer, public speaker, and a passionate advocate for women in technology. So we have really strong women here today with us, and we want to make sure that we, attribute that success that they have gone through right now. Thank you so much, Maja and Pooja, for being with us today. Um, Cool. I'll quickly move on to the agenda and I'll try to give a brief of what we're going to discuss today. So basically today the topic that we are going to touch in is Cortex and Copilot. So these are the two major Snowflake AI suite that we are going to touch upon today, and we will try to understand how to basically step by step optimize your queries. And there will be live demos for Copilot and Cortex both. So first we're going to cover the Cortex section, and then we're going to cover the Copilot section. So I hope you guys are all ready to get into this. First, my first question to both of you. Can you share like a little bit high level overview of what exactly is in Snowflake AI Suite and what is Copilot and Cortex in like a small brief?
So
Maja,
let me begin.
yeah.
Sure. Okay. So what makes this so interesting is that all of this is available inside Snowflake. So you have Snowflake Cortex, and you can use these functionalities from Snowflake. So from SQL, from Snowpark, from stored procedures, from queries, you can write Streamlit apps. So this is something that is really useful because you don't need any special kind of equipment installations and so on. You have many models available, and we'll speak more about that later in the demos.
Awesome. Pooja, anything you would like to add?
Yeah, Maya has stated it fairly well. So yeah, one I would say the brownie feature here with Snowflake AI suite is we really don't have to worry about any of the infrastructure. So we have things readily available, and as a data engineer, as a data architect, that's what matters to me, right? So I really don't have to worry about what models are plugged in, what GPUs infrastructure has been running. I can purely focus on to the data analytics and executing the analytical side of the data implementation. So that's where Cortex and the bunch of AI Horizon and the Cortex brings through Snowflake. Okay, and as specific to this particular webinar, we are going to discuss how we can leverage the Cortex AI suite, specifically focusing only two of the offerings. We know there are a bunch of things mentioned here on the screen, so we may not really see how Cortex search or analytics work, but we would see how we can use this to optimize the performance. And Copilot is same as any other AI LLM based assistant that we can see. And we would also have a quick demo on that too. So just to see how we can use it, where it lies, and what are the features it brings in out of the box.
Awesome, awesome. Cool. So moving on, I think the first part we will discuss is what is Snowflake Cortex? What are the key features? So Maya, any highlights over that?
Sure. Snowflake Cortex is a suite of various tools and functionalities. Mostly you will recognize them as these LLM functions, large language models. You can think of this as when you go to, for example, ChatGPT and you ask a question and you get an answer. That's a basic LLM. But in today's demo, we will see how we can do this from Snowflake. So ask questions and do other LLMs like sentiment analysis and language translation and so on. And we will also see various models. I will show a few of them. We'll see that some perform better, some perform less well, and we'll discuss that. And there are also some helper functions that we have because, Snowflake is in the cloud. You have to always be conscious about the cost. You need to know how to monitor. So it's called token usage. So each of these models uses tokens, and you need to be aware how you monitor it or how you estimate the usage upfront so that you don't overrun your costs accidentally. Because, if you're not careful, it can add up, and you need to be aware of that as well.
Awesome. Makes sense. So before we get into the demo, I think one thing that we would like to discuss is what sort of use cases Snowflake Cortex solves. So yeah.
So I already mentioned a few. So translate, for example, from various languages to various languages. More and more languages are being supported. So I think in time you will be able to translate anything to anything. You have data summarization, for example. So, you can give the LLM a huge text and it will summarize it for you. We have classification, like we already mentioned, or sentiment analysis, whether it's positive or negative or something in between. And these use cases are quite general. For example, sentiment analysis is often used with use cases where you have call centers and your customers call and you want to be able to quickly recognize whether they are complaining or praising or what is the general sentiment and so on.
Makes sense.
You can see there's a poll on the screen, so feel free to enter your answers.
Awesome. Then I think Maya, we can quickly talk about a few best practices and tips that you would like to give before we dive into the demo.
Sure. So whenever you work with LLMs, you're probably aware there's something called a prompt involved. So a prompt is basically a question that you ask. And probably most of you are already aware that you need to be able to craft the prompt so that the LLM understands your question, so that you are being clear, specific, what it is that you're looking for, so that the LLM can give you a good answer. So for sure, you need to be able to know how to tweak the prompts. I guess that's the major one for
Cool.
LLM. Mm-hmm.
Cool. I think then there were two things that you wanted to discuss about how to do this optimizing.
Yeah. So anyway, the theme of today's session is how to optimize query performance. So we've been talking about Gen AI LLMs up until now, But how can we use this for something that we do on a daily basis, which is, for example, in Snowflake, optimizing query performance, looking for queries that are causing bottlenecks. So this is actually what I will be showing you in the demo. First of all, how to identify the longest running queries, and then, of course, using LLMs, and then how we can use LLMs to optimize the queries and test the performance.
Awesome. So, not keeping everybody on hold, we can quickly dive into demo. Maja, you can share your screen.
Okay, sure.
Also, guys, while Maya is sharing her screen, if you guys have any question, please input into the Q&A tab. We can quickly answer those questions and questions towards the end of the webinar.
Okay, I've shared my screen. I hope everyone can see it.
Yes, visible.
Okay, so what I have here is a notebook in Snowflake. Probably you've seen notebooks before. It's where I can share text, SQL queries, results, and so on. So as mentioned, let's figure out how to optimize query performance by identifying queries that run the longest and then optimizing them. We will use the Cortex large language model functions, which we already mentioned. Here are some examples of the functions. And with these functions, we can use different models. Some of them probably sound familiar, like Llama, we've heard about this one. Snowflake has its own model called Snowflake Arctic. Just a couple of weeks ago, there was a big campaign announcing that Anthropic Claude is now available inside Snowflake, Claude Sonnet. I was really excited because just as I was preparing this presentation, this announcement came and I said, yes, I can include it and I will show you that it's really a good one. And then a bunch of other models, like I don't even know some of these, Gemma, Jamba, whatever. You can go to the documentation and you will get an up-to-date list of all of the available models because they do keep on changing and new ones are added all the time. Maybe if you're not aware, some of these models have these like abbreviations, suffixes at the end, like 3B. This means 3 billion. So it means that this model was trained on 3 billion data points. This one has 8 billion, so this one was trained on 8 billion data points. So in general, the larger the number in the suffix, the more data points the model was trained on, and the better it performs. But as I've already mentioned, probably it costs more. So you need to be careful and find a good balance between cost and performance. Okay. So now, how do we identify queries that run the longest? We probably know that all of the executed queries are available in the query history. We have an information schema query history view, and we have an account usage query history table. So for now, we'll just stay in the information schema, so we don't need any special privileges. But we know it's query history, but maybe we're not sure how to write the queries, what the columns are. So, just to save time, why don't we ask the LLM to write the query for us? Use the LLM like a helper or like something we might Google, but, just do it quickly. Go to Snowflake, ask it. There is a warning, and when you go to the Snowflake documentation, you will always also see it. You should always check the output of an LLM. And probably we've all heard LLMs can and do hallucinate. And by hallucinate, we mean the answer is not necessarily always correct. It's not because they're lying, It's simply because they were trained on a limited set of data, and if they know the answer, they know, and if they don't know, they'll find the best answer that they can. So it may not be correct. So always check what the model returns before using it. And this goes not just for Snowflake or for queries, for anything that you do, either with ChatGPT or with any LLMs. Always use your judgment and use your common sense. So let's write a prompt, and the prompt is, please write a Snowflake query that identifies the 5 longest running queries within the last 7 days. So we're limiting it to the last 7 days because we're not interested in queries that ran half a year ago. Maybe they have already been optimized since then. And one thing that I did have to put in is, please write a Snowflake query, to be specific that I want the query on Snowflake in Snowflake syntax. Because even though I'm running this from Snowflake, the LLM is a general purpose LLM. It doesn't necessarily know that I'm on Snowflake. So if I don't specify Snowflake, it might give me a query in some other syntax. So just keep that in mind, that these are general purpose LLMs. And I constructed the prompt. What I can do now is, like I said earlier, I just call this is just normal SQL. It's a SQL cell. Select the Cortex complete function. I'm putting in my prompt as the parameter, and I'm specifying Snowflake Arctic as the model I want to use. I chose one. I'll show a couple of different ones so that we can see what they return. And when I run this, I think I can run it. It took 5 seconds earlier, but I can run it again. Here is the answer. And just to make it easier to read, I already, because here it's very small, I already copy-pasted the answer into the next sheet. And what we can see here, the LLM wrote a query. It's a perfectly valid query, but it went to query history by session into this view, not the query history. Of course, because I wasn't specific enough, and it's thinking I probably want the queries in my own session. So, I could go back, tweak the prompt, and so on. So we don't have much time for the demo, so I won't do that. But, when you play around with this, you can try different prompts, and you'll see how the answer changes. Then I ran the same Snowflake Cortex complete query with the same prompt with a different model. So let's say llama. I just chose one of the llamas. And here is the output. So, same question, same prompt, different model, completely different query. This query is actually not incorrect, but I think it's way too complicated. Why is it doing this extract day? So again, I wasn't specific enough which columns I wanted and so on, but, it gave it its best shot. I tried with another model with Reka Flash. So this one is very inexpensive, and we can also see it's very, how should I say, not very accurate. So here it's saying select something from Snowflake audit log, which is not, it doesn't even exist, and it's not relevant for this query. So definitely hallucinating. And then I also tried Claude Sonnet. And this one really, really is a good one. You can tell already because, first of all, it returned 2 versions, one simpler, one more involved. And it also, you can read here, it gives you the whole explanation of how and why and what are the 2 versions and so on. But this one is absolutely correct, both of them. You will see that it did go to Snowflake account usage query history, which again is not incorrect. I could run this query if I had the privileges, so these are fine. So as I said, play with these models, play with the prompt, see what it gives you, and then choose a sensible answer. So this is the query that I finally executed, because I really need just a few columns. I only need the query text. And what I can see here now, so this is from this query history from what I've been executing right now. So you can see we did the select Snowflake Cortex. So if you were running this in your own account, you would see your own queries, which would probably be more meaningful queries, like selecting data from some tables. So let's say you finally tweaked your query to give you the longest running queries. They are all ordered by the elapsed time in descending order. So you would immediately see what these queries are and start with the largest, figure out whether it makes sense that it runs the longest, because sometimes some queries really do run long because they have a lot of data to retrieve or do complex processing. So again, use your judgment on whether you should attempt to optimize the query or not. And then once you found a query that you want to optimize, you can again go to the LLM and ask the LLM to optimize the query for you. And what you want to do to see if the query performance is indeed optimized, you want to run the query before optimization and after optimization and compare. Probably you're aware that Snowflake uses caching. There's several levels of caching, like warehouse caching and data caching locally and data caching remotely. So very often, if you run the same query twice, it will use the cached query results. But even if it's not the same query, like you're running the initial query and then the optimized query, you're still using the same data set. And still, the query might use caching from the local storage. And just to be sure that you have a fair comparison, what you want to do before doing any kind of comparison is to alter session, use cached result false. So set this parameter to false, which means that regardless what you have in the cache, Snowflake will not use it. This will give you a fair comparison of query performance. Do not use this in your production workloads, because you want caching to improve performance, but for testing you want to disable it, just so that you can always have a clean slate. And now here I have a couple of examples of queries that I tried to optimize. One thing that I have to say is it was really difficult to find examples of queries to optimize, because Snowflake does so much optimization already internally that even if you have a poorly written query, Snowflake might optimize it for you behind the scenes and you might not even know. So when I was just looking for examples, sometimes even a query that looked optimized to me had the same performance. And then when I looked at, in Snowflake, you can look at the query history, and it shows you the execution plan. In the query profile, you can see the execution plan, and the plans were the same. So you could see that it was already optimized. So, I just played with this a little bit, but I really do have simple queries, because many of you who work in real life environments, you probably have much, much, much more complicated queries. And that's where this really becomes interesting and useful for you. So here's just one simple example. So here I have a query that has a common table expression, a with statement, which when you look at the query is completely not needed. So it's written more complicated than it needs to be. And I ask Cortex Complete to please rewrite this query. And I specified without nesting the CTE. So sometimes you do need to kind of give it a hint what to do. And I used Snowflake Arctic and here is the rewritten query. And when I ran it, the syntax is fine. Actually, it did exactly what it was supposed to do. So simplified the query into one single query expression, picked only the columns that it needed. And this looks totally fine. Here's another example. This one looks very easy. So it's just select distinct, and I'm using Snowflake sample data here as an illustration. So I'm looking for distinct nations in the customer table in Snowflake sample data. And distinct is a keyword that often causes performance bottlenecks. So many times when you see that you have queries with poor performance, you might notice that they use the distinct keyword. And I always say, don't use distinct if you don't have to. But sometimes you have to, depending on what you're trying to achieve. So this one, we can see it took 1.1 seconds. And now I just asked the Snowflake Arctic model with the Cortex complete function, please rewrite the query for better performance. I didn't give it any additional instructions. And I passed in the query in the parameter. And here is the result that I got. And I copied the complete result. It's doing a group by. And it even gives you an explanation that the group by function is generally more efficient than the distinct function. So this is actually from the Snowflake documentation, and apparently the model knows. So this time it's taking 1.2 seconds. So actually I have very little data here, so it's not clear from this example, but you can see that the LLM does read the documentation and does know what it needs to do. So it did rewrite this query, and it explained why. So yeah, this is more or less the demo. Like I said, you should really play with this with your own queries and see what you come up with. I was also mentioning that you need to be careful or conscious about the cost. So you do have a couple of tables like the metering daily history, where you can see usage by service type, which is AI services. So this is for combined AI services. But the one that's a little bit more interesting for us is we can use the Cortex functions usage history, which is by Cortex function, where we can see which function we called, which model we used, and how many tokens. And this will give you visibility into how expensive it was and which models cost more, and just see how you see Sonnet is quite expensive compared to some of the others, and some of them are very inexpensive, but like we saw, the results are also different. So this is again something that you can play with and see for yourself. And to summarize, remember, always review the output of the model. Don't trust it completely, and track costs just so that you don't have any surprises at the end.
Awesome.
So this concludes my demo.
I think that was pretty insightful. So we have actually 2, 3 questions which I felt are very much relevant, and we can answer them right away. So there's a question which says, to get more accurate results, we should go for a higher model which is trained on the large data set.
Yes, absolutely. It's what I was also mentioning. Better models are trained on more data points, and they generally perform better. Yes, correct.
Awesome. And is there any way that we can fine tune the smaller model to give us accurate results, just like the bigger model?
Yeah, we've seen use cases where you can fine-tune the smaller model. There's actually a nice demo in the Snowflake Quick Starts, which gives you an example. And of course, you can do that. Of course, to fine-tune the model, you need to have sample data. So you would need to have queries unoptimized and optimized so that you give it like an input data set. So you would have to rewrite your own queries. But for fine tuning, you don't need huge data sets, so you can pass in just a few such rewritten queries, and it should perform better.
Awesome. Okay, so there's one last question for you, Maya, which is I think people are pretty interested in your notebook. Is that available anywhere, or can we share it with
It's in
the
my GitHub, actually. I don't know, should I put the link into the chat?
actually you won't be able
Or,
to. Zoom doesn't allow that. What you
oh,
can do
okay.
is I'll send it later on to the attendees. Please share that with me,
Mhm.
and I'll make sure that I transfer that.
Mhm.
Awesome. So Jason, we'll share the link with you. Cool. So I think one part of the webinar is complete where we talked about Cortex in pretty much detail, tried understanding where to choose what. So basically the ask was to optimize between either going for a model which performs better and or the model which costs more. So basically finding the right balance is the key here. I think we'll move on to Pooja. I'll quickly reshare my screen. Um, just a second. There is some glitch. Okay, weird. Yeah, cool. So I hope you all can see my screen. Moving on to Pooja. Um, Tell us a little bit more about what is Copilot and what are the key features.
Sure. Uh, Cool. So Copilot is just like any, you might have heard this term quite often these days, right? So most of the tools, they are adding Copilots as an AI assistant. So it's nothing but it's a LLM powered, AI powered SQL assistant, which is embedded along with the Snowsite. Snowsite is nothing but Snowflake's web UI through which we can perform almost everything that Snowflake offers. So AI assistant is available, which not only works for a SQL worksheet, it also works for the Python notebooks, and we can use it very well to answer our questions. So as Maya mentioned, right? So instead of searching something generic on the search engines like Google and some others, we can have, we can use AI assistant, ask the questions in simple plain English, and it has the capabilities to understand it, and it is trained on top of Snowflake documentation as well. So for example, you want to explore anything within the Snowflake platform which you are not aware of, you can ask and it would guide you to get a summary of the feature that you are looking for or any help that you're looking for to implement the feature. Along with that, it also helps to generate the SQL queries. So we can simply ask question, we can select what data set, what database and schema we want to use, and it reads through the metadata of the table, and it can generate us a text which would give us a better understanding. So let's say you have bunch of tables, but you don't know what is the, how you can use it in a better way to run any kind of LLM or ask what kind of questions to be asked. In that case, you can start, asking questions like provide me insights on the data. So it would read the metadata, and it would share the details in terms of what this table holds and how you can use the data. So these are the key, I would say, offerings or features of Copilot.
Awesome. Moving on to use cases, I know you kind of touched upon it, but what sort of use cases do Copilot solve?
Yes, so one thing I like the most is we really don't have to worry about using it. So we directly ask questions, whatever questions we want to have in a plain simple English, in a natural language, and it would guide us in terms of implementing, answering all the questions that we have. So as I mentioned, one is to deriving the insights on the data if we are not sure on what kind of data we have underlying and how we can use it. Another one could be the refining the queries. So it helps to design the query as well. So for example, take a use case where business users who might not have the technical skills, to use the SQL, to write the SQL queries. So in that case, they can come and they can put a simple plain, English asking for the question. So write me a query which gives an insight on the revenue for over the past year or maybe past couple of years. And this would generate a SQL query based on what type of underlying objects you have chosen. And it would show whether the query is valid or not, so that you can execute it directly from the chatbot itself, from the Copilot itself.
Awesome, awesome. So I think next, before diving into the demo, we have like a few best practices for Copilot.
Yes. There is also a poll on the screen. So yeah, we will look forward to hear from you guys if you have experience with this and what's the future. Yeah. So in terms of best practices, like any other LLM assistant, and even some of the examples Maya also shared. So we have to be exactly precise in terms of what we are asking. So try to avoid the generalized question if you're looking for something very much specific as I answered through Copilot. And as I mentioned, Copilot runs on top of data, and there is a feature where we can select what kind of a database and schema we can use. So we have a capability to refer to an object. So we can use @, as the same as the parameter that we typically use. So to refer to the object, so I can ask what this particular column means, what this particular table means, and it can help me to understand it further to drive the insights.
Awesome. So while we have a basic understanding, let's dive a little bit deeper into the demo.
Sure.
You can
I'm just bringing up the Chrome screen here. Let me know if you guys are able to see.
Yes, it's visible.
Okay, cool. So with respect to Copilot, as I mentioned, this is built in with the Snowsite. This is the Snowsite web UI. You guys must be aware of this Snowflake Snowsite. So we can launch this Copilot from the screen itself. As you see on the right-hand side bottom on the screen, we have a Ask Copilot. So this is nothing but it's a LLM-based AI assistant. And these are some of the top features or the use cases listed. So we can use to write it for queries, improve the performance. We can also explore. And as I mentioned, it also used for learning. So if someone is new and they have set up their trial account, so AI assistant Copilot is available for trials as well onto AWS regions. So you can use this to start with your learning exercise as well. So what we have to do is, once, for example, we want to run or maybe derive any data insights, then here is an option to select the database. So we can select onto which database we want to use. And we can also select the schema. So there are a bunch of tables present in this particular schema, if you see. And I don't know what this table holds. So I want to derive an insight. So we can also ask questions like, give me insights of table. So if we see, the moment I have put in @, it has started listing down the columns as well as tables. So we can pick up what it has, which one we want to pick, whether tables and columns, and you hit onto it. So it starts reading through the metadata of the table and columns, and based on the metadata information, it lists down the details of what this table holds, what are the columns, and what it brings to us. So this is more of understanding the data and getting insight if you're not aware of what kind of data is there. The second use case is in terms of getting the queries. Okay, so for example, we have this table. So for a demo, I have picked up the data set available as a part of Quick Start. So Cortex Analyst demo has a table, daily revenue by product. Okay, So what this is the query that generates the summarized revenue for the given product. So you can ask a question like how let me get this query here. So as I mentioned, there are two features here to build an example. It shows a valid query. If the query is valid and it refers to the same database and has the required permissions, we can directly run from here. If the query, for example, I have given the same query and asked how we can optimize. So for example, how to optimize. As this runs on a sample data set, it may not create any performance issue, but when we try to run any of the aggregates on the larger data sets, we definitely want to check on the performance and what are the optimization options. So this what Copilot does is it goes through this query and it suggests some of the I would say basic recommendations that we have around filtering aggregations, and it makes some changes and recommend how it should look like. And if you see, we get a non-executable here. So this shows there is an error, and this particular instance of the Copilot doesn't have access to run any queries on top of this. So this not only helps us to understand and provide the suggestions on the optimization, it also shows if there are any access related issues. So here I was able to run it earlier, and now I'm not able to run it. So if you see, it is available to a public role by default, and we can grant Copilot to any of the users using RBAC onto a database role, and we can manage the accesses through it. So that's all about Copilot and how we can use it to help us to write queries, optimize, and even guide us in terms of generating any insights from the underlying data. So yeah, back to you.
Awesome, awesome. Thank you so much, Pooja. I got to unmute myself. Thank you so much, Pooja. Thank you so much, Maya. So I think we are almost coming towards the end of the webinar, and we would like all of you guys to make sure and ask your questions with the experts right here. They have been with Snowflake and played around Snowflake for a really long time. I see there are two questions that are already there in the chat, and we'll quickly try to take these. So the first question is, can we use the open source Claude Sonnet model from Anthropic in case we do not have the access to Cortex function from Snowflake in our organizations?
I mean, of course, you can always take the open source model, but here we're discussing Snowflake, so we want to stay inside Snowflake. And if you go to the documentation, you will actually see that if a certain model is not available in your Snowflake region, you can enable cross-region support. So in the documentation, you will find what to do.
Awesome. Awesome. So there's one more question that we have. What's the difference between using Copilot and using LLM generation as a query?
Okay,
Yeah.
so I would say both of these, like Copilot runs on top of the underlying LLM that is already the LLM models that are already available in Snowflake. So if we don't have any, in case of LLM generation, we can specify what model we want to use. So there are a bunch of models available, and we can specify if we want to use any specific model. But with respect to Copilot, it is being made available with the default model that is underlined on Snowflake. There are also options where we can customize the Copilot. That's the key here. So yeah, Maya, you want to add anything?
You said it very well.
Awesome. One more question has popped up. So Copilot ensures that the query returned are executable in Snowflake without any error as they read metadata, while in case of LLM, it can be a possibility that query returns may not be executable.
That's well said, Sachin. Yeah. So
Awesome.
Yeah, we see that valid and not valid on the Copilot, whereas we are not sure with the LLM. It may or may not generate the exact query. Yep, well said.
Awesome. Guys, you have like a minute or so more. Please feel free to write down your questions right here. And we have also launched one more poll to basically try to understand how much you guys have gathered through this webinar. And this can be like a good startup point for all of us to even make it even better. So please feel free to answer that. Any more questions? We'll wait for a minute and then we'll probably conclude the webinar. Maya, Pooja, I think it was an amazing webinar. I, being from a non-technical background, have learned quite a lot during the whole process and even the webinar. So that's like a pretty big deal for me. Also, we do have two more questions. So one question is, Maya, what additional use cases are you excited about with Cortex in data engineering?
It's like every day I find something new. So yeah, there's so much. I'm especially excited about, the document AI, just getting information from unstructured data. And yeah, there's always something.
Awesome. And I think there's an appreciation for both of you guys here in the chat that thanks a lot for this informative session. I resonate with it. Cool. I think that's pretty much about it. And what we'll do is we'll quickly wrap up the webinar. Thank you so much, Maya and Pooja. We'll share the links. We'll also share a downloadable PDF of this so that you guys can go through it. And we'll also share the recording over emails. So please keep an eye out for that. Thank you so much, everybody, for attending. Thank you.
Having
Bye.
us.
Bye.
Bye.